Hello students and good afternoon to you all. So today I am doing class for class 12 science. The topic is problems on Lagrange's mean value theorem. And in the last online class we did problems on Rolle's theorem. So today we'll do problems on Lagrange's mean value theorem. So before we do problems on Lagrange's mean value theorem, you should know about the statement of Lagrange's mean value theorem. So in the last online class also I told you about Lagrange's mean value theorem. What is Lagrange's mean value theorem? We discuss about its statement and the geometrical interpretation of Lagrange's mean value theorem. So today we'll again revise the statement of Lagrange's mean value theorem. Okay. So now what is the statement of Lagrange's mean value theorem? Y is equal to f of x be a real valued function defined in the closed interval a less than or equal to x less than or equal to b, such that number one condition, f of x is continuous in the closed interval a less than or equal to x less than or equal to b. Number two, f of x is differentiable in the open interval a less than x less than b. So therefore there exist only two conditions must be satisfied out here. So there exists at least one value of x, say x is equal to c, lying between x is equal to c, lying between a and b, such that f dash of c is equal to f of b minus f of a whole divided by b minus a. Okay, so you know that capital A and capital B are the 2 points on the plane, isn't it? The capital A को coordinates कति हुन्छ a, f of a, and capital B को coordinates कति हुन्थ्यो b, f of b. So what is the slope of the straight line AB? The slope of the straight line AB will be equal to f of b minus f of a divided by b minus a. That is the difference of the ordinates divided by difference of the abscissa. You know that. So we can revise that Lagrange's mean value theorem. Okay. So in this case, f dash of c is equal to f of b minus f of a divided by b minus a. That means f dash of c भनेको चाहिँ के हो? That is f dash of c भनेको slope of the tangent at any point to the curve at x is equal to c. And what is meant by f dash of c is equal to f of b minus f of a divided by b minus a? That is the tangent at any point to the curve at x is equal to c is parallel to the straight line AB. Is that clear? f of b minus f of a divided by b minus a चाहिँ के थियो? Slope of the straight line AB, right? अनि f dash of c चाहिँ के हो? F dash of c चाहिँ के हो? Slope of the tangent at any point x is equal to c on the given curve y is equal to f of x. Is that clear? अनि f dash of c is equal to f of b minus f of a divided by b minus a भनेको हामीले के बुझ्यौं? Slope of the tangent to the curve at any point x is equal to c is equal to slope of the tangent at any point x is equal to c on the curve y is equal to f of x is equal to slope of the straight line AB. भन्नुको मतलब चाहिँ के हो? That is tangent at any point to the curve at x is equal to c is parallel to the straight line AB भनेको. ठीक छ? त तिमीले घरमा फेरि एकपल्ट यो क्लास सकेपछि तिमीले घरमा फेरि एकपल्ट Lagrange's mean value theorem को geometrical interpretation तिमीले रिवाइज गर्दा हुन्छ. ठीक छ? त अब हामी यो स्टेटमेन्ट युज गर्छौं in order to do this problem. Okay? So now this is question number 8, exercise 3B, 2 mark section, page number it is 307 from the same book, Higher Mathematics for class 12 by SND. Okay? So question number 8 is you have to verify the truth of Lagrange's mean value theorem. Formula for the following functions. You have to verify the truth of Lagrange's mean value theorem in this case. The function of x is given as f of x is equal to x square minus 4x minus 3 in the closed interval 0 less than or equal to x less than or equal to 4. As you know that every trigonometric function, every logarithmic function, inverse circular function, exponential function and polynomial function of degree n, these are all continuous and differentiable in its domain. Okay, so in this case f of x is equal to x square minus 4x minus 3. This is expression in terms of x, or this is known as polynomial function of x of degree 2, and this function of x is continuous and differentiable in the this is continuous in the closed interval 0 less than or equal to x less than or equal to 4, and this is also differentiable in the open interval 0 less than x less than 4. So we will write it here. So before that, let us differentiate it. So write down differentiating both the sides with respect to x, right? So this is your f dash of x is equal to, what is the differentiation of x square? 2x, then this is minus 4, right? Is that clear to all of you? Now what will you write here? The two conditions of Lagrange's mean value theorem must be satisfied in this case, okay? That is, the function f of x is continuous in the closed interval that is 0, 4, right? Then the function f of x is differentiable. The function f of x is differentiable in the open interval. Within first bracket 0, 4. So all the conditions of Lagrange's mean value theorem is satisfied here. So therefore there exists at least one value of x, say x is equal to c, lying between a and b. What is a and b here? It is 0 and 4. Lying between 0 and 4, comma, such that f dash of c is equal to, what is f of b in this case? F of 4, here b is 4, minus f of a is 0, divided by b minus a. What is b minus a? It is 4 minus 0. Here a is 0 and b is equal to 4. So this is f of b means f of 4 minus f of a means f of 0 divided by b minus a. What is b minus a? It is 4 minus 0. Is that clear now? So let us write down the value for f dash of c. What is f dash of c now? Since f dash of x is equal to 2x minus 4, you put x is equal to c in this case. What do we get? 2c minus 4, isn't it? So right here 2c minus 4 is equal to, now what is f of 4 now? What is the value for f of 4 here? So you can put x is equal to 4 out here. So it is 4 whole square, right? Minus 4 into 4. Is that clear? Instead of x you put 4 whole square minus 4 into 4 minus 3. Minus, within third bracket you put x is equal to 0 in this case. 0 whole square is 0. Minus 4 zeros are 0. Minus 3, right? It is minus 3. So let us write it within second bracket. Is that clear to all of you? So whole divided by 4 minus 0 is 4. 4 minus 0 is always 4. Is that clear? So let us simplify it. So it is 2c minus 4 is equal to, this is 4 whole square is 16. 4 whole square is 16. Minus 16 minus 3. This is minus into minus plus 3, right? Is that clear? So whole divided by this one is 4. So I think you have understood it. So this is 4 square is 16 minus 4 into 4 is 16. This is your minus 3, isn't it? So this is your minus 3, I think. Yes, this is your minus 3. So minus 3, so minus into minus plus 3. So here you can cancel 16, 3 gets cancels. Or 2c minus 4 is equal to 0 by 4 is 0. Or 2c is equal to 4. That means c is equal to 2. And you know that this c should lie between 0 and 4. So obviously these two lies within 0 and 4, isn't it? So here you can write, therefore 0 less than 2 less than 4. So there exists at least one value of x, say x is equal to 2, lying between 0 and 4 such that f dash of c, that is f dash of 2, is equal to f of 4 minus f of 0 whole divided by 4 minus 0. Is that clear? So hence what do we write? Lagrange's mean value theorem. Hence Lagrange's mean value theorem is verified. Hence Lagrange's mean value theorem is verified. So this is your answer. So now we'll do the next problem. So now we'll do question number 3 of number 8. In this case also you have to verify the truth of Lagrange's mean value theorem formula for the following function. That is, question number 3 is f of x is equal to root over x square minus 4 in the closed interval 2 less than or equal to x less than or equal to 4. So you have to verify the truth of Lagrange's mean value theorem for this function of x, which is equal to root over x square minus 4 in 2 less than or equal to x less than or equal to 4. So let us differentiate it first, right? So differentiating both the sides with respect to x. So this is your f dash of x is equal to, now you know that root over x. What is the differentiation of root over x? 1 by 2 root over x square minus 4 into, again you have to differentiate the function which is termed as x. That is, x square minus 4 is termed as x. Again differentiate it. What is the differentiation? It is 2x, right? So 2x minus 4 is, differentiation of 4 is 0. You don't have to write it. So here 2 gets cancels. Or that is your f dash of x is equal to x upon root over x square minus 4. Okay. Now whenever the values of x lies within 2 and 4 and x is equal to 4, this function of x is defined. That means f of x is continuous in the closed interval 2 less than or equal to x less than or equal to 4, because at this interval, that is when 2 less than or equal to x less than or equal to 4, this function of x is defined. That means the function f of x is continuous in the closed interval 2 less than or equal to x less than or equal to 4. So here you can write, therefore the function f of x is continuous in the closed interval 2 less than or equal to x less than or equal to 4. 2 less than or equal to x less than or equal to 4. Is that clear? So next, again, in the open interval, that is 2 less than x less than 4, whatever may be the value of x that lies within 2 and 4, but x not equal to 2 and x not equal to 4, for all these values of x, this f dash of x is defined. Okay, that means the function f of x is differentiable in the open interval 2 less than x less than 4. Therefore you write here, the function f of x is differentiable in 2 less than x less than 4. So I think you have understood it. So all the conditions of Lagrange's mean value theorem is satisfied. So you have to write, therefore all conditions of Lagrange's mean value theorem is satisfied, right? So therefore there exists at least one value of x. Therefore there exists at least one value of x, say x is equal to c, lying between lying between what? 2 and 4. Lying between 2 and 4 such that what do we write? Such that f dash of c is equal to f of b. What is f of b? Here it is 4 minus f of 2 whole divided by b minus a. Here b is 4 and a is 2. That is 4 minus 2. So is it understood now? So you can copy it. You can pause the video and you can copy all these things. Okay. So or f dash of c, or what is f dash of c now? So instead of x you have to put c here. So it is, if you put x is equal to c, so c divided by root over c square minus 4, right? So यो x को सट्टामा हामी के लेख्छौं? c. So f dash of c is equal to c divided by root over c square minus 4, which is equal to, what is f of 4 now? If you put f of 4 is equal to root over, कति हुन्छ यो? कति हुन्छ यो? Root over 4 square is 16 minus 4. 16 minus 4 minus, if you put f of 2, if you put x equal to 2 square minus 4, 4 minus 4 is 0. Square root of 0 is 0. So this whole divided by 4 minus 2 is 2. Is that clear now? So let us find out the value for c in this case, right? Now अब हामी c को value निकालौं. Therefore c upon root over c square minus 4, which is equal to, so on the right hand side this will be root over 12 divided by 2. Is that clear? So or this is c upon root over c square minus 4 is equal to, this is 4 3s are 12. What is square root of 4? It is 2. Root over 3 divided by 2. Here 2 gets cancels. So now you do cross multiplication here. So root over 3 into root over c square minus 4 is equal to c. So how can you get the value for c in this case? Squaring both the sides, remove its square root. So squaring both the sides. So squaring both the sides, what do we get? So squaring both the sides, what do we get? Or it is 3 into c square minus 4. Square root will be eliminated on the left hand side, and on the right hand side there is c squared, right? So let us simplify it now. Or 3c square minus 12 is equal to c square, or 3c square minus c square is equal to 12, or this is your 2c square is equal to 12, or this is your c square is equal to 6. So as c should lie between 2 and 4. C should be positive out here because it should lie between 2 and 4, isn't it? That is your positive. So you take only positive sign. C is equal to root over 6. So what is root over 6? So what is root over 6 now? Square root of 6. Let us get the square root of 6. Okay. Now 2 2s are 4, 3 3s are 9. That means 2 2s are 4. 2 2s are 4. Subtract it. 6 minus 4 is 2. So you can put decimal point here, add 2 zeros. So 2 plus 2 is, this one is 4, right? This one is 4. Now what will you write here? 4 4s are 16, 5 5s are 25. That means 4 times. This is 4 4. 4 4s are 16 goes 6. 1 4 4s are 16 plus 1 is 17. Subtract it. 10 minus 6 is 4. 9 minus 7 is 2. Right? Again double zero are added out here. And you add 1 in this, you add 4 in this case. So this is your 48. So 5. If you write 5 here, it will be 485 into 5. 5 5s are 25, 2, 8 5s are 40 plus 2, 42, 4, 5 4s are 20 plus 2 is 22. Oh, sorry, it is 4 4. 5 5s are 25. 2 8 5s are 40 plus 2 42, 4 5 4s are 20 plus 4 is 24. So this number is more than 2400. So it goes 4 times only. So 44. So approximately it is 2.44. So approximately C is equal to, what is root over 6? It is 2.44. And you know that this 2.44 lies within 2 and 4, isn't it? So here you can write, so therefore 2 less than 2.44 less than 4. That is, there exists at least one value of C. There exists at least one value of C, that is C is equal to 2.44, which lies within 2 and 4, such that f dash of C is equal to f of 4 minus f of 2 divided by 4 minus 2. So Lagrange's mean value theorem is verified. So therefore Lagrange's mean value theorem is verified. Hence Lagrange's mean value theorem is verified. So I think you have understood it, so you can copy it. So now we'll do the next question, that is question number 4 of number 8. You have to verify the truth of Lagrange's mean value theorem formula for the following functions. So f of x is equal to 2 sine x plus sine 2x in the closed interval 0 less than or equal to x less than or equal to pi. So you have to verify Lagrange's mean value theorem for the function f of x is equal to 2 sine x plus sine 2x in the closed interval 0 less than or equal to x less than or equal to pi. As you know that every trigonometric function is continuous and differentiable in its domain. So this is also the combination of two trigonometric function. So hence this combination of two trigonometric function is also continuous and differentiable in its given domain, right? So now let us first differentiate it. So differentiating both the sides with respect to x. So let us differentiate it now. Therefore f dash of x is equal to, differentiate sin x, it is cos x. So it is 2 cos x plus, what is the differentiation of sin 2x? It is cos 2x into 2, or f dash of x is equal to, this is your 2 cos x plus 2 cos 2x. So I think you have understood it. So here you can write the function f of x, is continuous in the closed interval 0 to pi. The function f of x is differentiable in the open interval 0 to pi, right? So all conditions of Lagrange's mean value theorem is verified here. So there exists at least one value of x, say x is equal to c, lying between 0 and pi, such that f dash of c is equal to f of b minus f of a divided by b minus a, right? So you have to write here, therefore there exists at least one value of x, say x is equal to c, lying between 0 and pi, such that what do we write? F dash of c is equal to f of b minus f of a divided by b minus a. So here what is f dash of c? So here f dash of x is equal to 2 cos x plus 2 cos 2x. So instead of x you put c here. So this will be 2 cos c plus 2 cos 2c. 2 cos 2c is equal to f of, what is b in this case? f of pi minus f of 0 divided by pi minus 0. Is that clear? So here you can take common now. 2 within bracket, you write first cos 2c. 2c is more than c. So cos 2c plus cos c is equal to, what is f of pi? If we put f of pi, x is equal to pi here, 2 sin pi is 0, sin 2 pi is also 0, isn't it? Because you know that sine of n pi is equal to 0 where n is any integer. So this is 0 plus 0 is always 0. Minus f of 0 is also 0, you know that. Sine 0 is 0, sine 2 into 0, sine 0 is also 0. That is also 0 whole divided by pi. Is that clear? So 0 minus 0 is 0, 0 divided by pi is 0. And since 2 is not equal to 0, you don't have to write 2 out here. So it is cos 2c plus cos c is equal to 0. So now in this case, on the left hand side, you can use a formula in this case to get the value for c. So you know that this is transformation of products and sums. So these sums should be converted into products. What is cos c plus cos d? You know that. What is cos c plus cos d? 2 cos of c plus d. What is c plus d? 2c plus c divided by 2. That is 2 cos c plus d by 2 into cos c minus d by 2. That is 2c minus c divided by 2, which is equal to 0. Okay. Since this 2 is constant, 2 is not equal to 0, so you don't have to write 2 out here. So it is cos 3c by 2 into cos c by 2, which is equal to 0. Now either cos 3c by 2 is equal to 0 or cos c by 2 is equal to 0. So now c should lie within 0 and pi, isn't it? There exists at least one value of x, say x is equal to c lying between 0 and pi. यो c को भ्यालु चाहिँ 0 र पाई को भित्र मात्र हुनु पर्छ. ठीक छ? So therefore cos 3c by 2 is equal to cos pi by 2 is 0, you know that. Cos pi by 2 is 0, isn't it? So what is the value for c out here? So in this case, therefore 3c by 2 is equal to pi by 2. You can cancel cos on both the sides. Here 2 gets cancelled. What is the value of c? C is equal to pi by 3. That is your 60 degree. So which lies within 0 and pi. Okay. So again here cos c by 2 is equal to cos pi by 2. That is c by 2 is equal to pi by 2. And here c is equal to pi. But in this case, c should not be equal to pi, because this value of c should lie between 0 and pi. 0 र pi को भित्र मात्र हुनु पर्छ. तो यहाँ कुन चाहिँ मात्रै छ? pi by 3 मात्रै छ. So there exists at least one value of x, that is x is equal to c, where c is equal to pi by 3, that lies within 0 and pi. So therefore you can write, therefore 0 less than pi by 3 less than pi. Okay, so hence Lagrange's mean value theorem, Lagrange's mean value theorem is verified. Okay, so this is the answer. So we'll do the next question now. Now we'll do the next question, that is question number 6 of number 8. Here also you have to verify the truth of Lagrange's mean value theorem formula for the following function. The given function is f of x is equal to x cube minus 2x square minus x plus 3 in the closed interval 0 less than or equal to x less than or equal to 1. So here the given function is polynomial function of x in degree 3. As you know that every polynomial function is continuous and differentiable in its domain, isn't it? So this function of x, that is this polynomial function of degree 3, is also continuous and differentiable in its given domain. Okay, so let us first differentiate it. So differentiating both the sides with respect to x. So it becomes f dash of x is equal to x cube. What is the differentiation of x cube? 3x square minus 4x. Then this is minus 1, right? This is 3x square minus 4x minus 1, right? So now this is the differentiation of f of x. Now you have to write the function f of x. The function f of x is continuous in the open interval, in the closed interval 0, 1. Therefore the function f of x is differentiable in within first bracket 0, 1, right? So all the conditions of Lagrange's mean value theorem is verified out here or satisfied. All the conditions of Lagrange's mean value theorem is satisfied. Okay, so therefore there exists at least one value of x, say x is equal to c, lying between which number? 0 and 1, such that f dash of c is equal to f of b. That means f of 1 minus f of a means f of 0 divided by 1 minus 0, right? So what is f dash of c now? Now f dash of x here is 3x square minus 4x minus 1, isn't it? So instead of x you put c here. So what do we get? 3c square minus 4c minus 1 is equal to, right? That is, this is 3c square. Instead of x you put c. 3c square minus 4c minus 1 is equal to, what is f of 1? You put 1 out here. 1 cube is 1 minus 2 into 1 whole square, that is minus 2, right? Then minus 1, then plus 3, right? So this is your, if you put f of 1, x is equal to 1, this is 1 minus 2 minus 1 plus 3, and if you put 0, what do we get? Minus, if you put 0 here, 0 minus 0 minus 0, you don't have to write it, so it is plus 3. It is only plus 3 whole divided by, so this whole divided by, what is 1 minus 0? That is 1. b minus a, that is 1 minus 0, which is equal to 1. Is that clear to all of you? So now let us simplify it, or 3c square minus 4c minus 1 is equal to, here 1 gets cancelled, 1 minus 1 0, 3 minus 3 0, so it is minus 2 only, or 3c square minus 4c यतापट्टि ल्याउँदा के भयो? -2 यतापट्टि ल्याउँदा +1 भएर आयो हैन? +1 हुन्छ हैन? -1 -2 it becomes +2 on the left hand side. +2 minus 1 is +1, which is equal to 0. So I think you have understood it. -1 plus 2 is +1, right? So now we can factorize it. You can factorize it. 3c square minus, now multiply गर्दा 3 आउनु पर्यो. दुईटा नम्बर multiply गर्दा 3, add गर्दा 4. That is 3 plus 1, isn't it? 3 plus 1 into c plus 1, which is equal to 0. Or this is your 3c square minus 3c minus c plus 1 is equal to 0. Or here 3c is common within bracket, c minus 1 common, this is c minus 1, which is equal to 0. Or c minus 1, 3c minus 1 is equal to 0. Either or garda c is equal to 1 or c is equal to 1/3. So this c should lie between 0 and 1. Here this c should lie between 0 and 1, but c is equal to 1. 1 is not valid here because 1 does not lie between 0 and 1, but 1/3 lies within 0 and 1. Okay, so here c not equal to 1, but You may take C is equal to 1 by 3 as 1 by 3 lies within 0 and 1. So therefore 0 less than 1/3 less than 1. So therefore Lagrange's mean value theorem is verified. Hence Lagrange's mean value theorem is verified. So it is done. So now we'll do the next question. So now we'll do the next question, that is question number 5. Is Lagrange's mean value theorem applicable in the given function? F of x is equal to 4 into 6 minus x whole to the power 2 by 3 in the interval 5 less than or equal to x less than or equal to 7 question mark. Okay. So you know the condition of Lagrange's mean value theorem. The function f of x is continuous in the given closed interval. The function f of x is differentiable in the open interval, that is 5 less than x less than 7. Let us first check that the function f of x, let us check whether the function f of x is differentiable or not in the open interval 5 less than x less than 7. So if it is differentiable, obviously it is continuous in the given closed interval. Okay, so let us first check whether the given function f of x is differentiable or not in the open interval 5 less than x less than 7. So here given is f of x is equal to, what is it? It is 4 into 6 minus x whole to the power 2 by 3. Okay, now write down differentiating both the sides with respect to x. Differentiating both the sides with respect to x. So this is your f dash of x is equal to 4 into, this is in the form x to the power n. So यसको differentiation कति हुन्छ? 2 by 3 6 minus x whole to the power, this is n into x to the power n minus 1. So decrease the power by 1, that is 2 by 3 minus 1 into, again you have to differentiate the term which is assumed as x. Which function is assumed as x? 6 minus x. So what is this differentiation? For 6 it is 0 and for minus x it is minus 1. Okay, so or f dash of x is equal to, this is minus comes in the front, minus 8 by 3, it is 6 minus x whole to the power 3 ones are 3, 2 minus 3 is minus 1/3, right? 3 ones are 3, 2 minus 3 is minus 1 upon 3. So therefore f dash of x, is equal to, how much is it now? Minus 8 upon 3 into, this is 6 minus x whole to the power 1/3. This minus this 6 minus x whole to the power minus 1/3 is simplified, it is taken to the denominator, so it becomes plus. Okay, but in this case if you put x is equal to 6, that is x lies within 5 and 7, means at x is equal to 6 this denominator is 0. If denominator is 0, this is undefined. So if x is equal to 6, so here f dash of x is equal to minus 8 upon 6 minus 6 is 0, which is infinity or undefined. That is, the function, this f dash of x is undefined when x is equal to 6. That means the function f of x is not differentiable in the open interval 5 less than x less than 7. Therefore, the function f of x is not differentiable in the open interval 5 less than x less than 7. So is mean value theorem applicable here? So here Lagrange's mean value theorem is not applicable in the given function. So hence Lagrange's mean value theorem is not applicable. Hence Lagrange's mean value theorem is not applicable. So this is the answer. So I think you have understood it. So you can copy it. We'll do the next question now. So now we'll do the next question, that is 4. There are two questions out here, number 1 and number 2 of number 4. Let's do question number 1 first. Lagrange's mean value theorem is f of b minus f of a is equal to b minus a into f dash of c. So you know that this is Lagrange's mean value theorem formula, and c lies within a and b. So number 1 is, what is given here? If f of x is equal to root over x and a is equal to 4, b is equal to 9, then you have to find out c. Okay, so if f of x is equal to root over x and a is equal to 4, b is equal to 9, you have to find out the value for c. So let us do question number 1 first. Okay, so what is given here? F of x is equal to root over x. So let us find out f of 4 first. What is f of 4 here? Which is equal to square root of 4, which is equal to 2. Then find out f of b, f of 9. That is f of 9 is equal to root over 9, which is equal to 3. Is that clear to all of you? So now let us write down this formula. Again f of b, you have to differentiate it first, right? You have to differentiate f of x first, because you have to get the value for f dash of c, right? So again, what is f of x here? F of x is equal to root over x. Now let us differentiate it. Differentiating both the sides with respect to x. So this is f dash of x is equal to, what is the differentiation of root over x? It is 1 upon 2 root over x. Is that clear now? So let us use Lagrange's mean value theorem formula. So it is f of b minus f of a is equal to b minus a into f dash of c. So let us put the value for b and a. So what is b here? B here is 9 minus f of, what is a here? 4, which is equal to, what is b minus a now? It is 9 minus 4 into, what is f dash of c? Since f dash of x is equal to 1 by 2 root x. So if you put x is equal to c, what is the value for f dash of c? 1 upon 2 root c. It is 1 upon 2 root over c. Is that clear? So, or what is f of 9? F of 9 is equal to 3 minus, what is f of 4? It is 2, which is 9 minus 4 is 5. 9 minus 4 is 5 into 1 by 2 root c. Is that clear? What is 3 minus 2? That is 1 is equal to, this is 5 by 2 root c. Is that clear? Now cross multiply it. Or 2 root over c is equal to 5. Or what is the value for root c? Root c is equal to 5 by 2. Now since you have to get the value for c, you square both the sides. So squaring both the sides, what do we get? What is root over c whole square? That is c is equal to, what is 5 by 2 whole square? It is 25 by 4. So this is the final answer. So what is the value for small c? So c is equal to 25 divided by 4. So is it clear to all of you? So we can copy it. Now we'll do the next question. That is question number 2. So you can copy it. Now we'll do, that is question number 2. Okay. So let's do question number 2 now. So now we will do question number 2. Now its solution is, what is given here? F of x is equal to ax square plus bx plus c. In a less than or equal to x less than or equal to b, you have to find out the value for c. we have to use the same formula here. Lagrange's mean value theorem formula is here. F of b minus f of a is equal to b minus a into f dash of c in a less than c less than b. Okay. So now here given is, so this is solution for number 2. Okay, this is number 2 solution. So given f of x is equal to ax square plus bx plus c. Now since the given formula is f of b minus f of a is equal to b minus a into f dash of c, so let us put the value for, let us find out the value for f of b when x is equal to b. So what is the value for f of b here? F of b is equal to ab square, right? So it is, so this is capital A b square plus capital B small b plus c. And what is f of small a, which is equal to capital A small a square plus capital B small a plus c. That is your f of b and f of a. Is that clear? Now let us find out the value for f dash of c first. How can you get the value for f dash of c? You have to differentiate this given function of x, isn't it? So given here is f of x is equal to ax square plus bx plus c. This is your capital C, right? So let us differentiate it. Differentiating both the sides with respect to x. So this is f dash of x is equal to this a, b and c are constant. Only you have to differentiate the variable. So it is 2 capital A small x plus capital B. Okay. So now you know the formula Lagrange's mean value theorem. So that is, since f of b minus f of a is equal to b minus a into f dash of c, that is your Lagrange's mean value theorem. Or what is f of b here now? This is capital A b square plus capital B small b plus capital C minus, what is f of a? This one is f of a, but you have to change the sign because there is minus sign out here. Capital A small a square minus capital B small a minus capital C, which is equal to b minus a into, what is f dash of c here? 2 capital A small c. So actually this is the continuation part, as there is no space there. So I have written here in the next step. Okay. So what is f dash of c now? Instead of x you have to put c. So f dash of c is equal to 2 capital A small c plus b. Right? So here you can cancel this, cc gets cancelled. Let us simplify it. Or from these two terms, what is common? Capital A b square minus a square, right? And from these two, what is common here? Plus capital B within bracket b minus a, right? So which is equal to b minus a into twice capital A into c plus capital B. Is that clear? Now let us simplify it further now. Or capital A into, what is b square minus a square? You know the formula, a square minus b square, that is a plus b into a minus b, b plus a into b minus a plus capital B into b minus a is equal to, so it is b minus a into twice capital A small c plus capital B. So I think you have understood it. So I am rubbing it. So here, or what is common on the left hand side? You b minus a ke aayo, common aayega. So b minus a is taken common. So within second bracket, what do we have? Capital A into small b plus small a, then plus capital B plus capital B, second bracket is closed, which is equal to, on the right hand side, what do we write? B minus a into 2 capital A small c plus capital B. So in this case also you have to get the value for small c. So from here you can cancel this b minus a, or capital A within bracket small b plus small a plus capital B is equal to twice capital A small c plus capital B. Again from both the sides you can cancel this capital B. or capital A into small b plus small a is equal to twice capital A small c. So here also this capital A gets cancels. So what is the value for small c? That is 2 is taken to the left hand side. If 2 is taken to the left hand side, you should write it in the denominator. So it is b plus a divided by 2. So this is the final answer. So what is the value for small c? Which is equal to b plus a divided by 2. So is that clear to all of you? So you can copy it. Now I'll give you the homework. So these are your homework. So the homework is question number 8. Verify the truth of Lagrange's mean value theorem formula for the following functions. So number 2 is f of x is equal to x square plus x minus 1 in the closed interval 0 less than or equal to x less than or equal to 4. Number 5, f of x is equal to x minus 1 into x minus 2 into x minus 3 in 0 less than or equal to x less than or equal to 4. Number 7, f of x is equal to x into x minus 1 into x minus 2 in the closed interval 0 less than or equal to x less than or equal to half. And number 8, f of x is equal to x into x plus 4 whole square in 0 less than or equal to x less than or equal to 4. So these questions are from the book. Okay. So you can do from higher secondary question paper also. So this is from HS 2018. 1C number 5, you have to verify here Lagrange's mean value theorem in the interval 4 less than or equal to x less than or equal to 6 for the function f of x is equal to x square plus 2x plus 3. You can easily do it. And from HS 2017 also, the problem is there. 1C number 2 is verify Rolle's theorem. In this case, you have to verify Rolle's theorem. You know how to verify Rolle's theorem, right? So verify Rolle's theorem for the function f of x is equal to x square minus 4x plus 3 in 1 less than or equal to x less than or equal to 3. Okay. And this is from HS 2016. 1C number 4, verify Lagrange's mean value theorem for the function f of x is equal to 4 into 6 minus x whole to the 2/3. 4 into 6 minus x whole to the power 2/3 in the closed interval 5 less than or equal to x less than or equal to 7. Okay. Now from HS 2015 you can do it also. You can try it at home. So verify Rolle's theorem for the function f of x is equal to 4 to the power sin x in the interval, closed interval, that is 0 less than or equal to x less than or equal to pi. So you try this problem number problem from HS 2015. So if you can't do it, then you can ask me, okay, or you can comment me and you can do it and I can do it for you. Okay, so just try this HS 2015. So if you can't do it, then I'll do it for you, but you have to write down the comment. Okay, so first you try HS 2015. Okay, so do all this homework at home and revise the problem that we did today. So this much is for today. So this chapters on Rolle's theorem and Lagrange's mean value theorem is finished. So in the next class we'll do the new chapter, that is second order derivative. We'll do second order derivative in the next online class. Okay, so you can copy it.